Welcome to 7th chapter probability, exercise 7.1, 7.2 solution. Rank the following events on a scale from 0, which is impossible, to 1, certain. Label each event as impossible, less likely, equally likely, more likely, certain. Give reason why you gave each event its ranking. That is the first subdivision. The next Monday will come after Sunday. So the rank here is 1 because this is the certain one. Rank is 1. Then we can label this certain. Why? Because we know the sequence. That is, the days of the week always follow a fixed order. Sunday is always followed by Monday. So we can label it a certain event and rank is 1. The second subdivision, it will snow in Mumbai, July. We know that Mumbai is a tropical climate. Mumbai has tropical climate. So it never have the where we cannot see the frozen climate there. So the rank is 0. It is an impossible event. We can label it as impossible. Third subdivision, an elephant will walk through your classroom today. So we know very well it cannot happen in our normal circumstance. That is normal situation. Elephant cannot walk in front of our classroom or in a school. So we can rank this as 0 and label the event as impossible event. If any special schools or classrooms in wild or a forest, then only it can, then also it cannot happen. So we can give the rank as 0. The fourth subdivision, you will get at least one friend at school tomorrow. So definitely when you are going to school, you may met many friends. Definitely at least one friend, you can wish at least one friend. So the chances are very high to wish at least one friend. The chances are very high. So we can rank this. You cannot rank it 0 or exactly 1. So you can rank this close to 1 or very close to 1. Then we can label this. Here more likely is given. So we can label it as more likely event. Exercise 7.2. A teacher mixes a large bag of sweets, different colors, and random selects a sample of 30 sweets. He count the number of sweets of each color. 10 red sweets, 8 green sweets, 7 yellow sweets, 5 blue sweets, 2 subdivision given. We will see that. Now here we are having in a large bag. In a large bag we are having some sweets. That is number of red sweets. Number of red sweets 10. Number of green sweets 8. And number of yellow sweets 7. Number of blue sweets 5. So n of s. N of s is nothing but n of red sweet plus n of green sweets plus n of yellow sweets plus n of blue sweets. So the sample space n of s, number of sample space 10 plus 8 plus 7 plus 5. So 10 plus 8, 18, 18 plus 7, 25, 25 plus 5, 30. So n of s, total number of sweets in the bag is 30. Calculate the probability that a random picked sweet from the sample is green. So we know that number of green is 8. Number of green sweets 8 and sample space n of s is 30. So probability of getting a green sweet So probability of getting a green sweet, out of 30 green sweets, we can pick 8. So when we are simplifying this, we will be getting 4 by 15. So if we want to find the decimal for this, we will be getting 0.267. You can divide and check. 0.267 is the decimal. So out of 15 sweets, we can get 4 green sweets, or out of 30 sweets, we can get 8 green sweets. The second subdivision, if there are 600 sweets in total in the large bag, estimate how many are likely to be yellow based on the sample result. Now, what is our sample result? Our sample result tells that n of s is 30, that is out of 30, we will be getting yellow sweets. N of yellow sweets 7. So, probability of getting an yellow sweet, getting a yellow sweet is 7 by 30. This is our sample information. Now we need to find the probability. We need to find the probability out of 600. So out of 30, 7 are yellow. So what for 600? When we are cancelling this, we will be getting 20. So 7 into 20 is 140. So out of 30, 7 yellow sweets, out of 600, 140 yellow sweets. So like this also you can find, or you can find equivalent fraction. 60 into 20, you will be getting 600. So 7 into 20, we will be getting 140. So out of 37 means, out of 600, we will be getting 140 yellow sweets. So based on the sample we got for the large number. Second question, a survey is conducted at a school where a random sample of 40 students is asked about their favorite club. The response are 14 students science club. So we will write number of science club students 14. Then 11 students arts club. So number of art students 11. Then 9 students sports club. Number of sport 9 students. 6 students debate club. So number of debate club students 6. So what is this sample space? N of S. Number of sample space 14 plus 11 plus 9 plus 6. So 11 plus 9, 20, 20 plus 6, 26, 30 and 40. So totally 40 students. Number sample space here is 40 students. What is the probability that a random chosen student from the sample prefers at art club? In our sample prefers the art club 11 students out of 40. So N of S, out of 40 students, art students are 11. 11 students preferred art. So probability of getting a art student is 11 by 40. Then using the sample result, estimate how many students in the whole school are likely to prefer the sports club. So here the sports club students 9. So this is our sample. N of S is 40 and N of sports students 9. So our sample giving the information, probability of getting a sports student out of 49 student. This is our sample probability. But in that school, the 800 students are there. Out of 800 students, how many prefers sports club? So like this only we can find the statistical data. We cannot go and check for all the 800 students. Using this sample, we can find for the number of 800 students, approximately we can find. So out of 40 we are getting 9, means total students 800. So out of 800, how much students prefers sports club? 9 into 20, 180. So probability of getting a sports student from whole school, that is out of 800, 180 students may choose sports club. So like this only, using a sample we can find a large number of scale. Toss a coin 20 times and record the result each time, head or tail. So this is a practical one you have to do by yourself. This is not theoretical one, it is an experimental probability. So we need to do it and we have to calculate the probability. I did it. So when I tossing 20 times a coin, I got, that is first subdivision, how many times did you get head? So I got number of heads, I got 12 times I got heads. How many times did you get tail? So number of tail I got 8. So totally 20. Calculate the experimental probability of getting heads. So now total probability, that is n of s here is 20. Getting head, I got head 12 times. So probability of getting head is out of 20 I got 12. So 4 table, cancelling 4 table, simplifying this, we will be getting 3 by 5. Out of 5 tosses, I am getting 3 times head as the outcome. Out of 20 tosses, I got 12 times head as the outcome. If you toss the coin once more, what is the probability of getting tail? Once more. So each and every toss is an independent toss. So that toss will not affect the previous one. So every time the probability of getting head or the probability of getting tail is nothing but out of 2, 1 chance. That is n of s, sample space for tossing a coin, either head or tail. So n of s is n of s is sample space. Sample space is head or tail. N of s is 2. So out of 2 chances to get tail, 1 only. So each toss is an independent toss. So each time we will be getting 1 out of 2. Either it may be head or tail. Fourth question, toss a paper cup into the air 100 times. After each toss, record whether the cup lands on its bottom. So lands on its bottom, here it is given. Lands on its bottom, upside down, on its top, or on its side. So upside, second one upside down, then the last one sideways. So these are the 3 outcomes. Assign probability to the outcome by using experimental probability. Again, it is an experimental probability, so you have to do by yourself. When I am doing myself, so n of s is 100. When I am tossing 100 times the paper cup, I got first one, bottom. I got the lands on bottom, suppose 23 times, and I got upside down position 51 times, and I got a number of sidewise position 26 times, totally 100 times. So if I want to find the probability of getting bottom position, out of 100 times, 23 times I got bottom position. The probability of getting upside down position 51 times out of 100 times. Probability of getting sidewise position 26 out of 100. You can simplify this, 13 divided by 50. Out of 50 times 13, or out of 100 26 times. Like that you have to do by yourself and check. What is the probability of getting an even number when rolling a fair 6-sided die? So we know that sample space of a die is 1, 2, 3, 4, 5, 6, all the 6 spaces. So n of s here is 6. Now probability of getting an even number. So what are the even number? 2 is the even number, 4 is an even number, 6 is the even number. So event of getting even number is equal to 2, 4, 6. So n of even number is equal to 3. So probability of getting an even number out of 6 chances, 3 chances. When you are reducing this 1 by 2, every 2 chance, 1 chance we can get an even number. Sixth question, suppose you roll a 6-sided die 12 times and get a 3 times. Get 3 times. What is the experimental probability of rolling a 3? That is here n of s, that is 12 times tossed means n of s 12, and the favorite outcome is 3. We got 3 times. So probability of getting 3. In the experimental probability, out of 12 times we got 3 times 3. So 1 by 4. The probability, experimental probability we got here 1 by 4. What is the theoretical probability of rolling a 3? So theoretical probability, definitely it should have the equally likely chance. 1, 2, 3, 4, 5, 6. These are the phases. So all the phases will have equally likely chance. So n of s here is 6. Number of 3 we can get only one time, exactly only one time. So probability of getting 3 here, 1 out of 6. That is the theoretical probability. Theoretical probability always based on the equally likely chance event. So we will be getting 1 out of 6 times. Then the next question, why might these probabilities be differ? What would you expect to happen if you rolled the die 60, 600 or 6000 times? So first one is experimental probability, next one is a theoretical probability. So the theoretical probability assumes a perfect fair die with all outcomes equally likely, but the first experimental probability is not like that. With only 12 rolls, the result we are getting 3 chances. So when we are at 60 rolls, the experimental probability will comes closer to 1 by 6, but may still vary there also. Like that 600, 6000 for everything. So the experimental probability, when we are increasing the experimental probability, it will approach the theoretical probability. This is called the law of large numbers.